Alright, welcome to page 2, and what we're going to do now is we're going to have a function of two independent variables, and we're just going to do a few operations. We're going to evaluate, we're going to find the domain, and then we're going to find the range of f. Alright, so let's go ahead and start with the first part, so a. So we're just going to evaluate f of 3 of 1, and so we have our function. And there is no x value to plug 3 in, but there is a y value to plug 1 in. So I'm going to have 1 plus the square root of 4 minus 1 squared. And so get 1 plus the square root of 3. And that is my solution for A. Alright, so here you're just substituting in your values and you're trying to evaluate what your function is at a certain point. Now for B, we want to find and sketch the domain of f. So when we're trying to sketch the domain, our domain is we're always going to sketch our domain in terms of how many independent variables we have. So here we have two independent variables. We have x, we have y. So when I sketch the domain, I'm sketching just in an xy plane. If I had 3 independent variables, then I'd sketch in a 3-dimensional plane. But since I only have 2 independent variables, x and y, that's what I'm going to be sketching in. So now what I'm going to do, I'm going to look at my function, and I'm going to look at what the function equals, and if there's anything that gives me certain limits to what I'm able to do. So one thing I know is that the square root, I'm not allowed to have a negative value underneath the square root. So what I'm going to say is I'm going to set my square root of 4 minus y squared. I'm just going to set that greater than or equal to 0 because that has to be greater than 0. And now, well, not just the 4. I know that has to be, but what's the determinant under the denominator cannot equal 0. I mean, it can equal 0, but cannot be negative. So I have 4 minus y squared is greater than or equal to 0, and so I'm just going to solve this for y squared. So I'm just going to move my y squared over to the right, and so I have 4 is greater than or equal to y squared, and then solve that. I'm going to take the square root of both, and when I do that, I realize that I'm going to have negative 2 is less than or equal to y is less than or equal to 2. So for my domain, I know that my y value has to be greater than or equal to negative 2, but less than or equal to positive 2. So there's my domain. So I'm going to write my domain in set builder notation. So I have my variables x and y. And because x, it's not defined anywhere, x can be all real numbers, so I'm not going to set any limitations there. But for y, I know that from negative 2 is less than or equal to y is less than or equal to 2. And there's how I write my domain. I just got to find out what, on the right side, if there's any, boundaries, if there's any limitations to what my function can be, either the x or the y independent variables. And so again, the obstacles that you're going to come up to is like typical obstacles. You can't have a negative inside of a natural log. You can't divide by 0, and you can't have a negative underneath a radical. And so those are going to be the times that you're actually going to be setting boundaries, defining the domain. So we found our domain of f, which is highlighted here. And one thing that we can do now is just graph. So we're going to graph this in 2 variables. So I'm going to go ahead and set so this is my domain, and this is my y, and that is my x. And I'm going to go ahead now and draw my domain. And so I know that I'm allowed to be, for my y values, I'm allowed to be anything between negative 2 and 2. And since I'm allowed to equal those, it's a solid line for both. If I was just less than or greater than and not the equal to, it'd be a dashed line. And again, again, I'm allowed to be all values for x. X is not even, a value in the function. And so there's my domain. All right. All values in between -2 and +2 for y, and then x can be any value. So now for C, we want to find the range of f. And if I want to find the range of f, then one thing that I know is that 0 is going to be less than or equal to the square root of 4 minus y squared, which is going to be less than or equal to 2. All right, now if this is the case, then I know 1 is going to be less than or equal to this 1 plus the square root of 4 minus y squared, which is going to be less than or equal to 3. So the adding 1 here is going to add 1 to both of those. And so the range for f is just going to be 1 to 3. All right, and again, if you have questions on how I know I'm going from 0 to 2, just think of the largest values and the smallest values you can be for y. The largest values we can be for y is 2. So 2 squared minus 4 is going to give me 0. So that's why I have 0. And then if I chose -2, I'd get back 0. Or if I plugged in 0 for y squared, the largest value I'm going to possibly get is 2. And so that's why it's from 0 to 2. And when I add that 1 in, then I'm going to add that 1 to both the 0 and 2 for my range. Right, so hopefully that answers that question. And we're finished. And so I'm going to highlight the answer there. And we're done. All right, now the next thing that we're going to do is we're going to talk about the definition of f as a function of two variables with domain D. Then the graph of f is the set of all points x, y, z in the three-dimensional coordinate system such that z is equal to f of x, y, and x, y is in the domain. So here we have a picture. We can visualize the graph of f as lying directly above or below its domain D in the xy plane. So if we're able to graph, the domain, then what we're doing is we're graphing just kind of like the shadow of whatever function that we really have. Now, on the right, I'm going to kind of give you some directions on how to graph, just because you don't really have anything on these note sheets. So just to the right, I'm going to say how to graph. And how to graph is not overly difficult. So the first part is we want to set f of x, y. So set our function to z. Kind of like how we said f of x is y. We're going to set f of x, y is equal to z. And then secondly, we want to try to get a surface that we know. So that includes, we know such surfaces like a sphere. But we also know from math analysis, maybe we could have something of a paraboloid or an ellipsoid. And so we're going to try to put our function in terms of a surface that we know. And I'm going to show you how we're going to do that in the next example. All right. And then 3, if you can't get into a surface that you know, you'll just use a computer. But in this class, I'm not going to give you anywhere, I'm going to expect you to use a computer. If I ask, I might, if that's the case, I'm just going to, in the problem will say basically use a computer to graph such and such. And so there are many, you can Google this on how to actually find 3D the graphs out there. Even if you want to even check your answers, I'm not sure when I provide you the answers, you can always use a computer to check. So here we're going to sketch the graph of the function, and we have a function of two variables, x or two independent variables, x and y. So the first thing we do is we're going to say, hey, y is equal to, not y, z is equal to 9 minus x squared minus 9y squared. And what we want to do is we want to put this in a surface that we know. So what I'm going to do is I'm going to move my x squareds and y squareds to the left, and I'm going to get x squared minus 9y squared is equal to 9 minus z. So I took my z variable and I moved that over to the right by subtracting, and I moved my x squared and my 9y squared to the left by adding. And the reason I did this is because if you remember from math analysis, what we're going to get here for problem 29 is just an ellipsoid. All right? And so we'll have, well, not necessarily an ellipsoid, but more like the elliptic paraboloid. All right? And, I'll kind of draw out what that is. So I'm going to go ahead and now draw this. All right, this is not perfect. So I can extend that just a little bit. All right, so one thing that we want to do when we're graphing this, I don't know why, I'm going to get rid of that. There we go. I'm going to go ahead and regraph. All right, and so here we have x, here we have y, here we have z. And one thing that I do know for x squared minus 9y squared, that when z is 0, if z was 0, I would have x squared minus 9y squared equals 9. And if you divide everything by 9, you're going to get x squared over 9 minus y squared equals 1. For here, we have an ellipse where for the x value, we're going to go, for the x-axis, we'll go a distance of 3. And for the y-axis, we go a distance of 1. All right? And then I'm going to go ahead and shade that in. All right? And then if our x squareds and y squareds were 0, all right? If our x squareds and y squareds were 0, and then our z value would just give us 9. And so that's where our elliptic paraboloid is going to start. And since it's negative z, it's opening up downward. So on the z-axis, I'm all the way up at 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm all the way up at 9. Because it's negative z, it's going to open up downward. And as we increase, our elliptic paraboloid is going to get smaller. And so that's not a good one. And so what's happening is that, we have this parabola that's opening up downward, and, it's continuing to get bigger as we go down on the z-axis. And so this is our elliptic paraboloid. Alright, and again, if you have questions on how to do this, let me know. And our vertex is going to be at 0, 0, 9. And it's facing downward because of that minus z there when we were solving. Alright? Again, if you do have a question, don't hesitate to ask on how to graph these.